Good morning, children. Welcome back to Ican Physics. Now in this class, we are going to see the capacitance of capacitor with dielectric. Okay, so let us consider a plate A. Okay, and another plate B. The plate A and B are separated by a distance of D. Let the plate A is given with a positive charge. Okay. So the negative charges will be induced in the inner side of the plate B. Okay. Then the outer plate is grounded. Now a dielectric is filled between the two plates of thickness T. Okay. Now the distance between the plates, is D. Now thickness of medium or thickness of dielectric medium is T. Then the thickness of air is D minus T. Okay. So we know very well that the capacitance of the capacitor is defined as the ratio of charge to the potential developed in it. Okay. So what is Q? Q equal to sigma A. Then it's taken as equation number 2. So how we can obtain? Okay. So surface charge density is defined as the ratio of charge to the unit area. The division area comes to this as multiplication. So Q equal to sigma A. Okay. So now we are going to calculate the value of the denominator, potential. Okay. So what is the relation between potential and the electric field? So dV equal to minus E into dx. But for our case, we are having two electric field. One is in air and another one is in medium. So we are having two electric field. One is in air, another one is in medium. Okay. So what is the electric field in air between the two plates? That is equal to sigma by epsilon 0. But for medium, sigma by epsilon. So what is the value of epsilon? Epsilon equal to epsilon 0, epsilon r. So by taking epsilon, we can substitute epsilon 0, epsilon r. So sigma by epsilon 0, epsilon r. Okay, now I am going to modify this equation. How we can modify? dV equal to minus E in air into dx plus minus E in medium into dx. Now plus into minus. So dV equal to minus E in air into dx minus E in medium into dx. So what is the formula for E in air? Sigma by epsilon 0. So minus sigma by epsilon 0 into dx. E in medium, that is sigma by epsilon 0 epsilon r into dx. That is equal to dV. Now in all of the terms, we are having differential form so that we can integrate on both sides. So when we are integrating, so dV equal to minus sigma by epsilon 0 into dx. Here what we are saying? Epsilon 0. So when we are using epsilon 0, electric field in air. So what is the thickness of air? D minus T. So that we can apply the limit 0 to D minus T minus sigma by epsilon 0, epsilon r. So that epsilon 0, epsilon r. So electric field in medium. So thickness of the medium is T. So that we can apply the limit 0 to T into dx. Okay. Do you get it now? Do you have any doubts? No doubts. Okay. So when we integrate dV, so it becomes V. equal to minus sigma by epsilon 0. So, if integrate panna, dx integrate panna x with the limit 0 to d minus t minus sigma by epsilon 0 epsilon r. Dx integrate panna x into 0 to t. Next upper limit minus lower limits. So, minus sigma by epsilon 0 upper limit minus lower limits. Okay, here minus sigma by epsilon 0 epsilon r upper limit minus lower limits. So minus sigma by epsilon 0. 0 minus something. Minus of something. Minus sigma by epsilon 0 epsilon r. 0 minus t. Minus t. Now minus minus. Minus minus. So it becomes plus. So sigma by epsilon 0 into d minus t plus sigma by epsilon 0 epsilon r into t. So before the plus, after the plus, we are having sigma by epsilon 0 as a common term. Okay, so that should be taken as common. So the remaining d minus t plus t by epsilon r, that is a value of b. Now it can be taken as equation number 3. Okay, just look at the first equation, q by v. So now we know the value of q, numerator value. In the denominator we are having v, now only we calculated. So substitute 2 and 3 in 1. So C equal to q. What is the value of q? Sigma a. Sigma a divided by v. So v value is sigma by epsilon 0. Sigma by epsilon 0 into d minus t plus t by epsilon r. Sigma getting cancelled. So the epsilon 0 becomes reciprocal. So epsilon 0 a by d minus t plus t by epsilon r is the capacitance of parallel plate capacitor with the dielectric. Okay, now do you get it now? Do you have any doubts? No doubts. So a parallel plate capacitor with the dielectric, that can be taken as C dash is epsilon 0 a by d minus t plus t by epsilon r. So in the previous question what we have studied, when the parallel plate 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 and outer plate. Okay, so what about the capacitance of the parallel plate? C equal to epsilon 0 a by d. Okay, now what about the effect of the dielectric? Okay, so for that I am going to see when the two parallel plate is completely filled with the dielectric. So when it is completely filled with the dielectric, d equal to t. Okay, so I am going to substitute here. So C dash equal to epsilon 0 a by d minus t. So d minus d plus t. So t is nothing but d. So d by epsilon r. So something minus something. So it becomes 0. So C dash equal to epsilon 0 a by 0 plus something something. So d by epsilon r. Now it becomes reciprocal. So C dash equal to epsilon r times of epsilon 0 a by d. So what is epsilon 0 a by d? Is C. So C dash equal to epsilon r times of C. So we know very well that the epsilon r is always greater than 1. So C dash is always greater than C. So when we are placing the dielectric within the two parallel plate, automatically the capacitance increases. How much time it increases? Epsilon r times increases. Okay, do you get it now? Do you get it out? No doubts.